Hello everyone and welcome to this course on modern application development.
Now that we have seen different forms of access control, let's look at the security mechanisms that can be used to implement this in the context of the web. So the first thing is, what are different kinds of security checks that can be applied in order to control access to a given application? Okay. And one of them, sort of the most trivial and also a pretty bad idea on the face of it, is what's called security by obscurity. And what obscurity refers to is something that is obscure is something which not many people know about, right? That's sort of the definition of obscure. And what I mean by that is, let's say that I take a regular HTTP application and instead of running it on port number 80, I then run it on port 1356. Okay? Something which is unknown except to the people to whom I sort of give the information out. So it listens on a non-standard port. That information is given out only to specific people, and therefore I think that only those who know that port will be able to access the application. Now this is generally a very bad idea. There are multiple ways of getting around this. One, of course, it could be as simple as, let's say, one of the people to whom I send it then accidentally just leaves the page open, or somebody walks past their desk and happens to see this thing open and sees the port number, right? And then they go and just sort of forward that information to a whole bunch of other people, and before you know it, everybody knows that there is this particular port out here. Now this might sound very silly, but the point is it has been done in the past, right? So don't sort of dismiss it and say, okay, nobody will ever do this. There have been cases where things of this sort have been done. Please make sure that you don't think of such ideas. Okay. You could put a further restriction which says the server itself will also check which IP address you're coming from. Okay? And this is what is called host-based access control. Right? And essentially what it's saying is that the server has access to the IP address from which the request came. And you might sort of whitelist certain IPs and say, only if you're coming from a particular IP address will you be allowed to connect. Now, this is in fact done in a lot of cases, right? Maybe not so much for web applications, but for example, SSH access, remote shell access to machines. Sometimes what you say is, I will allow you to access this particular machine only if you are logging in from some other known IP address, which means that you first need to be able to connect to that machine and from there connect to this new machine, right? And by sort of showing that you were able to connect to that first machine to start with, you have in some sense proven to the system that you have enough permissions to be able to get into this new machine. Okay? It has its own problems. It can be used in certain circumstances, but the biggest problem over here is that what if that intermediate machine somehow ran into problems and essentially got broken into? Okay? Then anybody who has access to that now suddenly has access to your secure application or your secure machine. So this by itself is usually not considered a good enough form of enforcing security. Now, login mechanisms are much better because they are sort of enforced at the final server level, right? Whichever server you are trying to access will itself put up a query asking you, saying, look, you need to give me a username and password. Okay? Now, how are username and password mechanisms implemented? We will look at a couple of examples of those later, but there are a number of different things that come up over here as well, and it's the full discussion of that is more or less beyond the scope of what we can do here, right? Including things like, okay, how should you be storing passwords? What should you not do with usernames and passwords? In particular, one of the things is the server should never store the passwords that it receives directly in text. Okay? Why? Because at some point the server might get broken into by someone who should not have access to it. At which point, they go look over there and find that all the passwords of all the people who have logged in here are available directly as text. And there's a good chance that a person might use the same password here as they do somewhere else. Okay? And what that means is, it's not only has your server been broken into, it has now opened up a whole lot of other servers also to potential attack. There are ways of getting around this. Usually what you do is you store one kind of a so-called hash of the password, which cannot be reversed, but it's uniquely identifiable. Like I said, it's sort of beyond the scope of what we can do here, For those who are interested, you can read up more about how security mechanisms are implemented. Now, apart from a username and login, right, there might be circumstances where, let's say that I want my laptop or my server machine to directly be able to connect to some other server somewhere and get some information. Okay, I need to be able to show that I am a valid user, but at the same time, I can't really sit over there and type in usernames, passwords, click on captchas, various other kinds of things, because it's just the machine or the script in the background which is supposed to do this connection. In such cases, usually what is done is, you have the final server and you have the client out here. The client will give some kind of a token which can be recognized by the server, and the token then basically says, okay, accept, and allows you to pass that information back. Okay, so only if the token is valid will the server respond to the client and give the information back as requested. This is especially useful for machine-to-machine authentication. It sort of replaces the idea of a password. Okay, it combines username and password into one token. The whole point is that the token should not be easy to guess. Okay, it's usually some long string. It can be arbitrarily long because after all these are just machines. They're just sending bytes one to the other. They don't need to remember anything. That information is going to be stored somewhere, either in memory or on the disk, right? So this kind of token can be used, especially in these contexts. Okay. Of course, you need to be careful to make sure that the token is not exposed. Nobody else can sort of see what is there in the token, because then they could use it. So these are all different kinds of security checks that can be implemented at the server end. Now, in the context of HTTP, right, there are a few mechanisms that are available, which we are going to look at now. The first is what's called the basic HTTP authentication. Okay, and this is part of the HTTP specification itself. It is enforced by the server, right? And you might have come across this in certain places where essentially what you get is that the server returns a so-called 401 code. Okay, so the 401 is a specific HTTP status code which indicates unauthorized. The client is not authorized to get this particular piece of information. Okay, so all the four codes in some sense are some kind of HTTP level status errors. Okay? The one that you are probably most familiar with is the 404, right? The not found. Okay, that just basically says that you ask the client the client asked the server for something, the server could not find what you were asking for, so it's giving you back a message saying, I don't know what you are looking for. Okay. There is also something called a 403, which is an outright forbidden. Right? It just says you are not allowed to access this. Okay. 401 is a little bit more nuanced than that. It's not saying it's outright forbidden. It's saying right now, given what we have, the information I have right now, you are not authorized. This client is not authorized to access this. So how should the client authorize themselves? Okay, and typically that is done by responding with some kind of an access token. Okay. Now this is an example of the sort of back and forth that would happen, and it's from the Mozilla Developer Network, right? What happens over here is, of course, the first thing, the client initiates the conversation. It gives a GET request to the server, and the server responds. Okay, so this is essentially an access of time. Okay, this is basically showing as time progresses, what are the requests that are sent back and forth. So as a client, I tried to request the /URL. Okay, the server basically responds with a 401 unauthorized, and in addition, it also gives me a www authenticate header, okay, which gives some information about the type of authentication that I'm willing to accept. And it basically says this is basic authentication, and this realm is a sort of identifier which says where you should go look for the password, right? So realms are just basically used in order to give some more clarity about what kind of login the server is expecting to see. Okay, and the reason you might have this is I might have multiple realms associated with a given site. Okay, so let's say that I'm a user who is basically connecting to a particular website, I might find that there's one realm associated with the admin dashboard, another realm associated with the user space, okay, and they might even be completely distinct from each other. Okay, that's probably an unnecessary way of doing it, but it's possible that I could do something on that side. Or, as in this case, it might say that there's a particular realm associated with the staging site, which means that the usernames and passwords that you use for connecting to a staging site, which is some temporary testing scenario, is different than what you would use in production. Okay, so that is why the realm is important. So once the client has got the realm, it will ask the user, right? One pop-up window will come over there and say enter your username and password. It will then send back this once again a GET request, but now it has an extra header, authorization basic, and this is some code, right? How is the code generated? It basically takes the username, the password, combines them together, and does something called base64 encoding. Right? Just puts the two together and converts it into a different format, which basically looks like this. Goes to the server will check the credentials. Whatever is encoded over here, it can decode, right, and find out what was actually sent. And if it worked, it will say okay. If it did not accept that username and password, it will basically say unauthorized again. And you can try once more if necessary. So the mechanism itself looks straightforward. What are the problems? The first thing is that, like I said, this thing over here is essentially uses something called base64 encoding, which is very easy to reverse. Okay, so if I take a username and password and put it through base64 encoding, then I can just do a base64 decoding and get back the username and password. So anybody who sees this token basically knows your username and password. Okay. Now, of course, what that means is that I need to make sure that nobody can get that information. Only the client and the server are allowed to see that. Okay. And we will get to that problem a little bit later when we are talking about wire level security. So some minimal security is possible if HTTPS is used, but the problem is that the password will still be seen as clear text. Clear text meaning the actual password that you typed in, ABCD1234, right, whatever it is that you typed, will be visible to the server. Now you might think, okay, obviously the server needs to check if the password is correct, but that's a problem because it means that the server now has the password. It's sitting somewhere in the server's memory. It might potentially get written into disk, and the server itself had the raw password sitting somewhere in it so that it could check. Okay. How else can you do this? Like I said, the one-way functions, the hash functions that can be, there are things that can be used in order to convert the password into something else, which the server actually does not need to store at all. Okay. And finally, one other problem with HTTP basic authentication is there's no standardized process for logging out. Okay. Strangely enough, they have this thing where as long as you keep giving that token, the authorization token, it basically says, okay, you are logged in, you can continue, right? But there should be some way of explicitly logging out and saying, I don't want to continue this connection, right? Let's say that I want to go away. I'm done with this. I was using it in some public kiosk. I can't log out. Okay. One way is usually to sort of shut down the browser and so on, but it's unfortunately not standardized. So it's possible that some browser might still retain your username and password. A slightly better variant of HTTP basic authentication is what's called digest authentication. Okay. Now, in digest, what happens is that, like I said, all of this now starts coming into the realm of cryptography. And cryptography essentially deals with how to store and transfer secrets. Right? Crypto essentially stands for secret. So cryptography deals with how you can use mathematical functions, right, and mathematical properties to say that certain kinds of operations are going to be very difficult to perform and therefore can be the basis of securely transferring data from A to B. Okay. Now there is something called a one-way function. Okay. The idea of a one-way function mathematically is very simple. It basically says that I have some mathematical function which takes in a number A and it generates a number B. Okay. Now I'm saying number, but remember that it could even be a string, right? An ASCII string at the end of the day is just a set of bits, which means that I can think of it as a number if necessary. So I could think of that A as either a string or a hexadecimal value or a binary value, right? Whichever way it is, at the end of the day, it's just basically a number. And f of A is a function which takes one number and converts it into another. Okay. Alternatively, I could also say it takes one string and converts it into another string. Okay. Now, what are the properties of a one-way function? The forward function is easy to compute. That is, if I am given A, f of A is easy to compute. On the other hand, it's nearly impossible to do the reverse. That is to say, if I give you B, can you get back A such that f of A is equal to B? Okay. Normally, we would call this f inverse, right? And this is nearly impossible to compute. Okay. There are ways to prove this mathematically, right, for certain kinds of functions. So those functions are chosen as the so-called one-way functions, and digest authentication essentially does some kind of complex set of operations with such functions. Right? The way that it does is it also uses the concept of something called a nonce, right, which is basically a number used once. Right? And what that means is the server has some kind of internal random number generation of its own, and whenever the client tries to connect, it generates a nonce and sends it back to the client. The client must now prove that it has certain information with it, right, by creating a new secret value which includes this nonce, right? And an example of that would be that you take the username, the realm, password, and pass it through MD5, which is one of the functions, right? It's a one-way function that we discussed earlier. Create another HA2, which is again an MD5 function of some other string. Finally, take HA1, the nonce, HA2, add them all one after the other and create an MD5. Why are you doing all this? Just to make it that much harder for a person who is trying to break this system to be able to invert all of these functions. Right? Even if they somehow manage to invert one MD5 function, right, which is, as it is, quite difficult to do, they would now need to do this multiple times in order to get back and get all the way down to the password, which ultimately is what we need. Okay. So the server and the client, on the other hand, know all of these parameters, which means that they can compute the same secret value on both sides. And the client has shown to the server that it was able to compute the same value that the server did. Okay. Any third party who snoops on these values, even if they see the response, will not be able to make anything useful out of it. Okay. And because it's a nonce, it's a number used only once, it means that each and every time you are trying to access, you will recompute this. So even if a person somehow manages to get hold of one of these tokens, right, they can't invert the functions and get your password, and they can't use this same value again because the nonce would have changed. Okay. So digest authentication is slightly better in that way than basic authentication. Okay. There is yet another form of authentication which is called a client certificate. Right? Now, most of you are probably familiar with HTTPS. Right? We'll be talking about that again shortly. But HTTPS, at least you know that these are secure websites. Right? Secure in what sense? Secure in the sense that there is some certificate that the server is showing you, right, and providing to you, which you have reason to believe is authentic. Okay, we'll get to that in another part of this lecture. Now, in the same way, I could also do the other thing. Okay? I could say that a client needs to show some information to the server to convince the server that it is an authentic client. Of course, normally we do that by using passwords. What we are saying is you could use the same kind of mechanism, that server certificate, but now do it on the client side, right? And the client now is able to establish to the server that it has some information which only that particular client could have known. Okay? It has a specific certificate which was issued by somebody that both the server and the client trust, and therefore this server can happily trust this client. Okay. Now, like I said, this is just yet another of the mechanisms that can be used. Ultimately, all of these things have very similar kinds of problems, right? You need to make sure that the client certificate is kept secure. Nobody should be able to go in and just steal the laptop and get the client certificate off from it, right? If that happens, then you have essentially lost the security of the thing. So physical security might be as big a problem as anything else in this context. Now, what happens when we are using an HTTP form, right? So in a form input, usually the username and password are entered into the form and are transmitted over the link to the server, right? So the username and password pretty much have to be sent as plain text. Okay. Now, at least the one thing that you can try and do over there is you try and secure the link between client and server so that nobody can sort of tap into it and directly see the password. But you also need to make sure that the password is provided in a reasonably secure manner. In particular, if you are using GET requests, what happens with GET? There is no concept of a request body. Okay, you only have the URL encoded data, right? So after the URL, you would basically have some question mark and let's say username equal to something, right? And password equal to something else, right? And if I have a string like this is a very bad idea because requests that are sent like this are very often logged. Even the server itself will directly take the request and store it in its log file, right? In between, if there is some kind of a proxy server, that might also take it and store it into log file, which basically means that the password is now sitting out there in the log file as plain text, and you don't know who has access to those files. Okay? So GET requests are generally very bad idea for forms that have usernames and passwords. Don't use them. Right? But POST requests are better that way. At least they don't get locked. Okay? And you can use it in order to send this information. If you combine a POST request with a secure link, which is established by HTTPS, that's pretty much as good as you can do at this point. Okay? Now, each request that is going from the client to the server requires a certain degree of security, right? And one way of doing it is I have one server, one client. The client establishes a connection to the server, right? If I need to have it in such a way that for each and every request I need to make a new connection, then for each and every connection I need to re-establish my authentication. Okay? On the other hand, if I can somehow keep that connection alive and send multiple requests across it, that's good news, because as far as the server is concerned, it's not possible to break into a connection midway. Okay, that is sort of guaranteed by the network level itself. It says that unless you were involved in setting up the connection from the beginning, it's not possible for a third party to come in and suddenly start feeding new information out here. Okay. So if you can do a single connection, keep it alive and have multiple requests going across it, that at least reduces the overhead required. It doesn't change your security requirements, it just sort of reduces the number of times you need to do this back and forth. Now, all of these were mechanisms that are available with the core web itself. There is one more mechanism that is available which is commonly used and which we will talk about in a little bit more detail later. For now, I just want to sort of mention the idea. And this again is a term that, pretty much every day I'm sure you are coming across some page or the other where it says this site uses cookies, click OK to accept, right? So what's a cookie, right? A cookie is just, once again, a random number or a random piece of information which the server sends back to a client, right? It might be after having checked whether the client is allowed to authenticate, or it might just be something for tracking, right? It might be, okay, I'm sending this to the client, and the next time this client comes back to see me, the client should give me the same cookie. That helps me to say, oh, okay, wait, I saw you last Thursday, right? That's where you left off. Now, what shall we do now? Okay. So a cookie is just, remember that the HTTP protocol was stateless or is stateless, right? Meaning that the server doesn't know what the client's present state is. A cookie is a way of getting around that. By sending a cookie along with each request, the client is sort of constantly updating the server and the server can then change the cookie, send it back, and the next time it gets back this cookie, it knows exactly what was the last part of the conversation it had with the client. Okay, so this cookie can be used in order to create a sense of state. It is a piece of memory that is shared between the server and the client, right? And that's exactly what state means. Okay. The idea is that the server can basically use this header set cookie in order to set some kind of information. There are some additional parameters such as which domain is it valid for, should it be used only on an HTTPS link, and so on, right? This finally also says it shouldn't be used with JavaScript requests, only with HTTP, something of that sort. So there are a few sort of extra parameters you can set with cookies. But the main thing is that a client must take whatever cookie it has received from the server and send it back along with each request as part of the header information. Okay. Now, by looking at these cookies, the server can maintain sessions for clients. Right? It basically says, okay, I've got this cookie from the client. I last saw that client so such and such time ago. This is what they were doing. This is the page they were looking at. Right? Send back something corresponding to that. Next time a request comes, once again the cookie is there. The server has this information that this is what it sent last to the client, and this is how it can update it. Okay. Now, the server then, for doing that, it needs to remember all the cookies it has sent. It can set timeouts. It can also just delete a cookie at the local end and say, look, this client is logged out. Start from the beginning again. Okay. Now that gives a lot of power both to the server and the client. On the server side, what it means is that it can enforce login, logout, right? It can time out people and disconnect them if necessary, right? On the client side, you can just refuse to send any cookies, which is what is the so-called incognito modes, right? Or the private browsing modes in browsers. At least they don't send the usual cookies that were there. They might still accept cookies in certain cases, but then they're just going to delete them after the session is over, right? Which means that every time you open a new private browsing window, it sort of doesn't send cookies again to the server. The server thinks this is a new client that's coming along, establishes a new connection, and after all that, when you close the window, all the cookies are deleted and not used again. Okay. So it gives some amount of power both to the clients and to the servers. Now, finally, a word on the API level security, right? So APIs are also things where, as we saw in the example of coding, right, booking appointments and so on, you might want to have authentication or some form of security. Now, cookies typically require some kind of interactive use. They need a browser. It can be done in some cases with the command line as well, but it's a bit harder to do that. And in particular, if we come back to the 401 code and you need to pop up a window for authorization, an automatic client is not going to be able to do that. So for access to APIs, typically servers also provide another mechanism which is related to something called an API key. Okay. So what's a key? I basically register with the website, maybe with GitHub or with the coding people who are organizing that, and they issue a token to me. Okay. And what that token means is I need to keep that token safe. I shouldn't share it with anyone else. But on every request that I send to the server, I just need to attach this API key header and send the token along. The server will look at that and say, okay, I know that I issued this key to such and such a user. They are allowed to access these parts of the system. Give them back the information. Okay. Good news, of course, is that the server can also invalidate tokens. It can set a timeout on them. Right? Lots of things. It gives the server a fair degree of control. And as far as the client is concerned, if somebody accidentally stole your token or you exposed it somewhere, you can go to the server and delete the token and say, look, don't accept this anymore. Issue a fresh token.